Unit 1 review questions. Number 1. What is the density of an object that has a mass of 34 grams and a volume of 12.3 centimeters cubed? For this one, I just divided the mass by the volume, so our typical density equation, and we got 2.76 grams per centimeters cubed. Question number 2. If a material has a density of 7.5 grams per centimeter cubed, what would the mass of a 1.75 centimeter cube sample of that material be? And my answer was 13.125 grams. Now, to think about this is that the 7.5 grams, the 7.5 grams per centimeter cubed, that's equivalent to saying that if I had 1 gram, this 1 gram would have a mass of 7.5 grams. And if I double it, I have 2 centimeters cubed. So I have 2 of them. I'm doubling the volume, and what I'm doing is I'll double the mass. So if I had 2 of them, I would have 15 grams. Okay? Number 3, what is the volume of a sample of material that has a mass of 13.2 grams and a density of 18.6 grams per centimeters cubed? I just divided the mass by the density, and I got 0.70967 centimeters cubed. Now, next one, these are some conversion problems. How many millimeters are in 57.7 meters? And all I did was I just used conversion factors to convert it to 57,700 millimeters. And number 5, how many milligrams are there in 5.6 kilograms? So I just multiplied my mass times 2 conversion factors. So first I converted it to grams, and then I converted it to milligrams. And I got 5,600,000 milligrams. Number 6, how would you know a reaction was endothermic and exothermic? In simple terms, an endothermic change is going to feel cold to the touch, since it's absorbing heat energy from the environment. Where an exothermic reaction is going to feel hot to the touch, you actually would feel heat radiating from it, since it's releasing heat energy. Number 7, how is a sample of matter changed from a solid to a gas? Now remember, if you compare the amount of kinetic energy in a solid compared to a gas, the gas has a lot more kinetic energy. So therefore, in order to convert it from a solid to a gas, I need to simply add heat to it. And as I add heat to it, the molecules start moving or vibrating initially, and then moving faster and faster until they separate. Number 8, which state or states of matter has a volume that is not fixed? And gas is the only one. Number 9, which metric unit is used to measure mass? And we use grams for that. Number 10, how do you distinguish between a heterogeneous or homogeneous mixture? A heterogeneous mixture, the composition is going to vary throughout. Or a homogeneous mixture, which is a solution, the composition is the same throughout the mixture. And number 11, what is the difference between mass and weight? Now, weight is a function of the gravitational pull that's being exerted on it, where mass is just the quantity of matter. Number 12, an object moves from the Earth to the Moon. Which will change, its mass or its weight? Only its weight will change. The quantity of matter is not going to change, so its mass is not going to change. Now, in reality, all objects that have mass have a gravitational field. So, for instance, as you stand on the ground of the Earth is pulling on you, and you're pulling on the Earth. But the gravitational field is so much greater from the Earth than it is from us to the Earth that we can't sense it. And the larger the mass is of an object, proportionately, the stronger the gravitational pull is going to be. So if an object is moved from the moon to the earth or vice versa, it's always going to have a greater weight on the earth and a lesser weight on the moon. Why? Because the earth is about 6 times larger than the moon. So it's always going to have a greater mass. A greater gravitational pull on it, so it's going to have greater weight. Question number 13. How can kinetic energy of an object be increased? Kinetic energy is the energy of motion, so something always has to be moving in order for it to have kinetic energy. But you can also increase the speed of an object, or you can increase the mass of the object while it's moving. So, for instance, if I have 2 cars, I have a small car that has a mass of 1,000 kilograms, and another car that has a mass of 5,000 kilograms. They're both moving at the same speed. The car with the higher mass is going to have a increased quantity of kinetic energy. Number 14, how can the potential energy of an object be increased? The simplest way is just to move it to a higher elevation. You could also theoretically change the the bonds holding it together, or the bonds within the molecules that form it, and change those so that they are bonds that have more potential energy, for instance. Number 15, explain the difference between chemical and physical properties. Chemical properties can only be observed if you actually change the substance from one type to another. In other words, it has to go through a chemical reaction. An example is if you want to find out the temperature at which paper burns, you have to heat it up until it starts burning, and then you know the temperature at which it burns. But in doing so, the product of that change is no longer paper. It's going to be mostly carbon dioxide and water. A physical property, you don't need to chemically change the object in order to observe it. So, for instance, how hard or soft it is something you can observe without actually changing it chemically. Number 16, if an object undergoing a change is cold to the touch, is that an exothermic or endothermic change? Explain your answer. So because the object is cold to the touch, it's absorbing energy from its environment. So that's an endothermic change. Number 17, how would you know if a substance like frosting on a cake is a pure substance? You would know because the frosting is going to vary throughout. Also, you can physically separate it. So if I want to separate frosting, because it's not going to be just made up of sugar, there's going to be other substances in there like colorings. You could physically separate them, let's say with a filter or equivalent. Number 18, give an example of a pure substance. And this obviously is going to vary, but water would be an example. Number 19, is alphabet soup a homogeneous or heterogeneous mixture? Explain why you answered the question with this answer. It's a heterogeneous mixture. And the reason why is because every time you pick up a spoonful of the alphabet soup, the composition of the letters is probably going to be different. Number 20, the change of a metal in a solid state to a liquid state is what kind of change? And that's melting. Number 21, how many centigrams are in 400 kilograms? So I used 2 conversion factors on this. I converted kilograms to grams and then grams to centigrams. So there's 1,000 grams in a kilogram. That was my first conversion factor. My second conversion factor was that there's 100 centigrams to a gram. So I came up with 40 million centigrams. Number 22, how many millimeters are in 45.6 kilometers? I used 2 conversion factors. I first converted my kilometers to meters, and then my meters to millimeters. So there's 1,000 meters in a kilometer and 1,000 millimeters in a meter. So those are my 2 conversion factors. And it came with 46,600,000 millimeters. Number 23, how many grams are in a 100.4 kilograms? And so I just converted my kilograms to grams. So it was a simple conversion. So I used my conversion factor of 1,000 grams per kilogram. And I came up with 100,400 grams. Number 24, how many kilometers are in 250 millimeters? How many kilograms are in 250 milligrams? So I'm really going the opposite. I'm going from larger units to small units. From small units to larger units. So I started 250 milligrams. I converted to grams. So 1 gram over 1,000 milligrams. And then I converted milligrams to kilograms. Grams to kilograms. So there's 1 kilogram is 1,000 grams. And I came up with 0.00025 kilograms. How many kilometers are in 34 centimeters? So again, I'm trying to convert a small unit to a very large unit. So there's 34 centimeters, and I converted centimeters to meters. So 1 meter over 100 centimeters. And then kilograms to meters. So if you notice on here, when I did this, when I multiplied the 34 centimeters times this first conversion factor, what I did was I ended up with a conversion factor that canceled out the units that I don't want. So I want to get rid of my centimeters. So I'm going to multiply times the conversion factor, where the centimeters are on the bottom, and on the top is going to be the unit that I want at this stage. Then I multiply times a second conversion factor, and I want to get rid of my meters in this case. So it's kilometers over meters, so that the meters cancel out and left with kilometers. And the answer is 0.00034 kilometers.